Hello, Cisco cohort. It's time to get going for today. Today I'm going to cover Chapter 5, Switch Configuration, PowerPoint slideshow. And then coming up next week, our first class on Monday is a lab day. I'll have a short session that day. I'll show you how to go into, just review how to go into the Packet Tracer program and how to get started in those two labs. So let's just quickly show a picture of the my TCC screen. I'm using the Chapter 5. Let me make it show the whole thing here. I don't want to do it for me. This one right here, Chapter 5. Switching security is the PowerPoint slideshow that we're going to start covering now, and that'll be the material that we'll cover for today. Okay, hang loose. I'll bring that slideshow up. Okay, the first few slides I'm not going to go through again. Those are duplicates of what we covered last time. Just looking for new people in attendance here. Let's review the startup boot up process of a router or a switch, which is almost totally identical with the boot up process of a desktop PC computer running Windows or Linux. When a desktop PC boots up, it performs a power on self-test to make sure all the hardware is okay and there's no shorts. Then it goes into the read-only memory, and the read-only memory, the ROM BIOS, has a routine that goes and looks for something to boot up. So in a desktop PC, that would normally be your hard disk drive or your SSD, solid-state hard drive, and it would boot up the Windows operating system or maybe the Linux operating system. There are strange occasions in defense plants or something like that where you don't boot from the hard drive, you boot from a network file server. Normally though, we boot from a hard drive or an SSD type drive. After the Windows boots up, it goes into the Windows registry and looks for things like what's your password, what color do you have the background screen, where your icon's located on the screen, and it loads those up. If you don't have a hard drive, if you have a hard drive with nothing installed on it, you'll get something like no boot drive or something like that on the screen, and you'll pull out your CD-ROM, your DVD-ROM, or your flash drive, and you'll install an operating system. Like, for example, if you're A+ type building your own PC. So Cisco routers and switches use a very similar scheme to this. They have a ROM memory, and it does the power on self-test. Then the bootstrap code in the read-only memory wants to boot up something. And almost all Cisco routers, that's going to be the flash drive, which is used in place of a rotating Rust hard disk drive because it's much more reliable and would last for many years without having to break down, whereas a hard disk drive might fail after 4 or 5 years. The problem with flash drives is, as we know, when you copy to a flash drive, they're really slow. So instead of running the operating system from the flash drive is loaded into RAM memory, and then it's executed from RAM memory, and that's makes it much more quick. Windows does the same sort of thing. He loads his program subroutines and modules. He loads them into RAM memory and makes Windows operate faster. So if you want to make Windows perform faster, add more RAM memory to your PC. Once the iOS boots up, it goes and looks for the presence of a startup configuration file in the NVRAM. And if that's present, if the router or the switch has been previously configured, it will then load your startup configuration file with your password and your IP address and all the other configuration you've done on that particular machine. Oops, sorry, double click. Just like on a desktop PC, you can dual boot maybe Windows and Linux. So on a router or a switch, you can have more than one operating system if you have enough room in the flash memory. Now, and all ones in the lab, and most normal routers and switches will just have one copy of the operating system loaded. But if you wanted to, for example, if you were in a production environment and you wanted to test a new release to a bug fix release to make sure it didn't break your operating environment, you could load into the flash memory a second copy of a newer iOS, and by using the boot system command, save the boot system command to your startup configuration file, you can point to which one you want to boot up when it boots up. So on Cisco routers and switches, the image file is in a folder with the same name. So if we do the dir flash command or the show flash command on this particular example of this slide, you see an example of the file name for the iOS. It's version 1.5, 15.0 of the iOS. And our switches in our lab have a later version than this. They have 15.2. They have a more updated version. Now looking at the hardware, looking at the front panel, there's some lights on there. Later on, when we do password recovery, we're going to look at that mode button and use that as a means of being able to reset the password if you get a job and no one knows what the passwords are for the routers and the switches. But there's lights above every port that light up to tell you if you plugged a wire into that port. They normally turn orange for a few seconds where he's checking for broadcast storms and loops, and then it turns green where you're actually a link light, like a link light on the Ethernet card on the back of your PC will light up. And there are some lights on the left-hand side that you can use the mode button to change it to say, do I want the light to indicate is it full duplex or half duplex? Is it 10 megabit? Is it 100 megabit? Is it gigabit Ethernet? Is power over Ethernet on that one? And those lights indicate that sort of a thing. So I'll skip past that. That's boring stuff. Okay, normally you don't have to configure a switch management interface or a VLAN address on a switch. Out of the box, it's going to operate just fine. It's going to be a layer 2 data link layer switch and very efficiently move Ethernet frames around your system. But if you want to telnet into it or secure shell into it from a management workstation, you would configure an IP address on it. The IP address is layer 3 things, which is your layer 2 beasts. But if we want to manage them over the Ethernet connection, we can apply code like this. Define an interface and apply an IP address to it and do a no shutdown command. And then that has the switch now has an IP address that'll respond to pings. And you can manage it from someplace else in the environment. Now, just like a desktop PC, a switch needs a default gateway address. If you're going to try to, in this diagram, the PC is directly plugged into the switch. He doesn't need a default gateway on the switch. But if you wanted to go to some other subnet that was on this network and be able to get to that switch by its IP address, you have to define a default gateway for the switch, just like you would have to define a default gateway for the PC1 so you could communicate with it. So on this particular device, he's typed the show IP interface brief command, and we see that the VLAN address that's been configured on this is up and up, and you should be able to ping it and address it from some other location. Now, switches are full duplex, which means there's enough wires in Ethernet cables to both be able to send and receive at the same time. If you plugged it into one of the old hubs are half duplex. They would have to downshift and sort of backward compatible go to hub operation. So let's get rid. Don't be in the hub. Hubs are dumb. Don't be in the hub club. We don't use hubs these days for anything except maybe security, tracking a device, or something of that nature. Okay, so half duplex is only one connection at a time. If we plugged into the old hub, we could have collisions. Only one workstation could transmit at a time. Full duplex is better because we have all devices can send and receive at the same time. They have private virtual channels, and nobody will interfere with anybody else. Oh, no, so I'm just putting some attendance in here. It's possible to configure the speed manually. Automatically, Ethernet will try to do the highest speed that's capable, that both parties are capable of, the highest capabilities of both parties. So if I plug a 10 megabit laptop into a gigabit switch, it'll downshift to the slow 10 megabit speed that the laptop has. We can go in and configure these manually if we want to. Auto sensing has gotten very good over the past few years. Normally doesn't give you a problem, but if you need to adjust it, like maybe using a Cisco switch with another brand of switch, you might need to manually override and do this. So I can go into the configuration mode for that port and manually make it 10 megabit old legacy Ethernet or 100 megabit fast Ethernet or 1,000 for gigabit Ethernet, and I could force the duplex to be half or full. So we used to have a problem that we plugged two switches together, and one would decide he wanted to be full duplex, and the other would decide that he needed to be half duplex. So the full duplex switch thinks he can send whenever he wants to, but the half duplex switch thinks he's sending while I'm sending. There's a collision. And so the administrators would have to go to both switches and manually configure them both to be half duplex or both to be full duplex to fix that particular problem. So if you're connecting to a known device, it's okay to manually configure these duplex settings. So if you're configuring to attaching to a server or a dedicated computer-assisted drafting workstation or network device, maybe a printer, you might manually configure these because some of these old devices were their auto circuitry and their MDIX and so forth wasn't that great. What is MDIX? That's a feature that normally you would have to use a straight through cable between, say, a PC and a switch port. But if you connected two PCs to each other, you'd have to use a crossover cable. Or if you connected two routers to each other or two switches to each other, you'd have to use a crossover cable. The electronics have gotten much better now, so almost all devices come with something called auto MDIX, which means that even if you use a crossover cable where you should have used a straight through cable, or if you use a straight through cable where you should have used a crossover cable, the transistors will automatically flip the wires around and make the connection proper for you. So in the lab now, we've got all auto MDIX on all our devices. We got rid of our last generation of routers. They were not auto MDIX. But so long as one of the parties is auto MDIX, it'll, as we say in East Texas, it'll gussy up the connection. It'll fix it for you. So you can make this MDIX auto, or you can do the manual settings yourself if you want to. So that's why in the lab we have both crossover cables and the little gray brown ones. We have straight through Ethernet cables, the yellow ones, and we have the flat cables, the rollover cables that we use for connecting to the console ports. So we can verify this with a show setting, show controllers, and it'll tell you that auto MDIX is on, which is the default for this. Okay, I'm just going to do a quick check of attendance here, see if I'm missing anybody. Okay, good. We're in good shape. Okay, here are some commands for verifying switch port configuration. So show interfaces shows us a whole paragraph of information about that particular interface. We're probably most interested in, like, is it up and up or down and down? Show startup configuration shows us what we've saved. Show run shows what we're operating right now. If we make a change and we haven't saved it yet, it'll be different. Show flash shows us the file name of the operating system. Show version will show us what version of the iOS operating system is there, how many Ethernet ports are there. Show history shows us the previous commands we have entered. And then, of course, my favorite command, one of my favorite commands, show IP interface brief, will show us information about all the ports on the switch or router. Is it up and up? Did I forget the type no shutdown? And then on the switches, we have our show MAC address table, which will show us everything is memorized in the past 5 minutes or so as to what your MAC address is, so it can be an efficient switch. So if we're looking at access layer issues, here's some possible combinations. Shown in, it should be yellow on you guys' screens. At the top, it says it's up and up. Everything's on the up and up. Oh, good. It's up and up. The first up is physical layer. The second up is data link layer. So if you plug a cable in and the other end of the cable is plugged into a device that's operating, that's enabled, you'll get this. If it's up and down, That means the wire is plugged in, the electricity is flowing through the wire, but the encapsulation type is not correct. Maybe a hardware problem. If it's down and down, there's no cable plug-in probably. There's not even any data link layer, any physical layer bits. If it says administratively down, you didn't type the no shutdown command yet. Now keep in mind that in switches, out of the box, with no configuration whatsoever, because a lot of these switches ship into small and medium-sized businesses, never get configured. That by default on a switch, they're not administratively shut down. You can just put the switch in a small business and plug the wires in, it'll start working. And then nothing is administratively shut down but the VLAN management port. You have to enable that one. So if you show IP interface brief and you see something's administratively shut down, you need to enable it, do a no shutdown to get it up again. Ethernet frames are supposed to be no smaller than 64 characters or bytes or octets, and no bigger than 1,518 bytes or octets. Anything that's smaller than the 64 byte is called a runt. It's normally a collision fragment. Anything bigger than the maximum allowed is called a giant. That's probably a bad network interface adapter. If you get a bunch of RSE errors, that means that some of the bits are getting flipped along the wire connection between the two. Probably a wiring error, maybe the gold pins on the RG45 connectors are corroded or something of that nature. Sometimes just unplugging the cable and plugging it back in again will fix it. Otherwise, try replacing the cable. Okay, no collisions should ever occur on a switch because you have a private collision domain to each employee desktop PC that's plugged into that switch port. If the employee puts a hub in his office and connects things together, they could create collisions. Late collisions are usually cable too long, or one end is half duplex, one end is full duplex. So we can correct that by reconfiguring those switch ports. Okay, Wireshark program is the program that shows us what's going on inside the wires. We can look at all the layers. So for example, this PC is connected to port 23 of the server, which is the telnet port, and we can run the Wireshark trace and see what's going on in it. Now, what's the problem with telnet and FTP? Clear text, no encryption, even passwords. So if you connect to a telnet server, FTP server, I'm going to be able to run the Wireshark on it while you do it, and I can see your username and password. And it's probably the same username and password you use in everything else because most people seem to have a hard enough time remembering just one password, not let alone 2 or 3. So you should use a password manager or something like that. So if we use Secure Shell instead, then when we try to look at that password, it's going to be encrypted. We won't be able to see what it is. Not only the name and the password is encrypted with Secure Shell, all traffic is encrypted. So that's safer if you're in a public environment like a coffee shop. Okay, secure access using Secure Shell. You can use PuTTY, you can use Teraterm, and you'll click the radio button for Secure Shell instead of Telnet. And it encrypts all the data. So regular old Telnet, port 23, encrypted Secure Shell. If you're going over a link that you don't have control over, like the internet, a Secure Shell is safe. Not all switches support Secure Shell. Not all iOSs support Secure Shell. The last generation of switches we had in the lab were the Model 2950s, and their iOS did not support Secure Shell. They couldn't perform the encryption because we have to have the encryption code, the public-private key pair thing. So if it has a K9 somewhere in the iOS file name, that means it does nothing to do with dogs. K9 means encryption. So all the modern iOSs have K9 in that file name, which means they do support encryption. If you're not sure, type show IPSSH, and if it's working, it'll show you that it works. If it says it's an unrecognized command, you've got an older device that does not support encryption. So to configure Secure Shell, we have to do this arcane command, IP domain name, and make up a domain name. You can make up any name you want to on a private network. You just use Cisco.com as an example. And then we're going to do a one-time generation of the public-private key pair with this command in red, crypto key generate. That's going to generate a key pair. I don't recommend sticking with the 512 bits. Go to at least 1024, or if you're on a public network, you probably want to go to 2048 or 4096 to generate this key pair. Once this is done, it's stored in the machine's MBRAM, and it'll be there for you to use in the future. Then we're going to create a username and password. Use it like you do on a server. You create a username, a student username, and his password. So he's created the username admin and the password class, so that when you log into the Secure Shell client program, it'll ask you to put in the name and the password, and then you'll be able to see that. Then we're going to go to the line VTY015, which we normally would say password Cisco login, and just use regular telnet. But in this case, he has specified with that line transport input SSH. Don't use telnet; it's unsafe. Only use Secure Shell. And instead of saying just log in, say login local, and that means use that username admin secret password class that we made up. And you can make as many users as you want to if you want to track your guys in your environment. Then you go to a Secure Shell client program like PuTTY or TerraTerm, click the Secure Shell button, type in the IP address of the management address of that switch, and the first time you do it, you're going to get a thing on the screen that says, do you accept the key exchange? And after that, all you have to do is put in your name and your password, and you'll be able to connect to the device. So in this case, the user has gone to the DOS prompt and typed in his username and password, and they're not shown on the screen. And then he's logged into the device, and he can do the configuration just like if he was plugged into the console port. So in this case, with a switch that actually supports encryption, on the top prompt, he says show IP SSH. It says it's running version 2. Some of the newer machines support version 3. The keys have been, in this case, they did a 1000-bit key. And when you type show SSH, it'll show you that there's 2 people that are logged into the Secure Shell server on this switch. So you can check what users are logged in. Okay, switch have vulnerabilities. People can try every password in the world, or do a denial of service attack, or do a Cisco discovery protocol attack, or maybe flood the switch's MAC address table with so many addresses that he stops being a switch and demotes himself to a hub, and now you can hear everything on every port. Another thing we'll look at is DHCP attacks, the dynamic host configuration protocol attacks, where you try to set up a rogue DHCP server and insert yourself as a man in the middle. So as a best practice in Cisco Network and Academy Labs, what we'd like to do is disable the ports we're not using, disable Cisco discovery protocol if we don't need it, and we can configure port security and DHCP snooping. We'll look at port security later on in this chapter, and you'll do that in the lab. Okay, so I want to shut down all 24 ports of a router. I want to shut down all 20 ports on a 24-port switch, and I have to go to each one by one. So there's a command interface range. In this case, he's specified, I want you to go to ports 20 through 24 and shut down all those 4 ports, all those 5 ports at the same time. That's easier than typing a single command over and over again. Cisco Discovery Protocol is a wonderful protocol that's wonderful to use within our corporation, so we can see what's connected to what. It's also necessary for Cisco telephones. Cisco telephones use Cisco Discovery Protocol to ask the switch, what's my parameters, what's my phone number, so they can download that information to the telephone and make it operate properly. Don't use Cisco Discovery Protocol to your internet connection to the outside world. You tell them everybody what iOS version you're using, and they're going to look for, they'll look for a vulnerability in your particular system. So you can disable Cisco Discovery Protocol, which is on by default on all Cisco devices. You can disable it globally on the entire device, or you can disable it on a port-by-port basis. So on this slide, he said no CDP run. That turns it off totally on the whole box. If I want to leave it running on all my ports inside my company, like from my phones, but a port that goes to my internet service provider, I can do no CDP enable on that individual port, and people on the outside world won't be able to scope me out. Okay, let's review MAC address table. We looked at this before, but we have some devices connected together. The switch has just been rebooted. of course, the MAC address table is going to be empty. So let's get some action going in here. And PCA is going to ping PCB. And as soon as PCA sends out his ping request, the MAC address table is going to learn that that MAC address is associated with that port number 1 that he's plugged into. As soon as PCB replies with his ping reply, the switch will learn that that particular MAC address for PCB is plugged into port number 2. And then when we look at the MAC address table, we'll see those two devices' MAC addresses and what port numbers they're associated with. Now, if a switch sends out, PCA sends out the ping request to B, and when he first sent it to port number 1, no MAC addresses have been learned yet, so he had to flood it. He hadn't learned PCB's source address yet. So what a switch does when he encounters an unknown unicast, he treats it like a broadcast. He floods it out everywhere. As soon as PCB replies with his ping request, reply, it'll be updated and the flooding will stop. A flood attack is something designed by a malicious intruder, a threat actor, the bad guy in the black hat, to try to flood your switch with enough bogus entries so that the MAC address table fills up. And once it fills up, everything is treated as an unknown unicast and gets flooded to all ports, including the one that our bad guy stuck into the wiring closet and plugged his device into. So now he gets to hear all the traffic on the whole company network. So these utilities can generate enough MAC entries to flood out any switch. So in this case, the bad guy is stuck into the wiring closet. He's plugged into the dean's computer, number B. The dean's always gone to meetings. He'll never notice. And the MAC address table is full, so everything gets flooded to all the ports, and he gets to snoop on all the secret company data. He's a spy from Dallas Community College. He's trying to steal our marketing plan. Oh, no. And we'll never know it because after he leaves, the MAC address table will go back to normal. So how do we fix this? Something called port security. We're going to be able to configure a port to say only authorized MAC addresses, like the real dean's computer, gets to use that port. If anybody else unplugs the dean's computer and plugs in their device, they won't have the right MAC address, and the port will not allow their data. They won't allow them to send and receive any data. So the switch port security command, you go to port number 2, which the dean's plugged into, and you can type in switch port security and how many maximum MAC addresses are allowed. And in case a bad one is detected, what do I do? And then there's a neat option called sticky, which means we don't have to manually write down everybody's MAC addresses and key them in. So it'll just learn them because switches learn MAC addresses anyway. So we can set the maximum number of MAC addresses to find what happens if a violation occurs. And we'll look at the next slide how we type in these addresses or have the switch learn these addresses. So a static address is, I'm going to go and write down all the MAC addresses for all the 200 machines in the computer science building. And then I'm going to key them in, and they'll be added to the running configuration. So if I could get, let's see, I'll just pick on somebody today. So Joshua Dixon, run to the computer science building. Oh, you can't, it's locked. And write down all the 200 MAC addresses. And if you could get that done by 10 o'clock today, that would be great. But that's too much of an error. Writing down all those addresses and keying in 200 addresses in, you're not, are you going to make 0 errors when you do that? But it's an option as static. Dynamic is, well, they're dynamically learned anyway by the switch. He puts them in the MAC address table. So I can have them learn them dynamically. But our black hat intruder, he's very clever. He unplugs the switch and plugs it back in again. And when the switch reboots, the MAC address table is empty. And then he gets in there real fast before the legitimate guy gets in there. So I like sticky, because this way, when the dean has real computer is plugged in, he gets a new computer, we plug it in, the switch learns the dean's legitimate authorized MAC address, and he stores it in the address table, and it's added to the running configuration. And then I'll do a copy run start. And so if the bad guy unplugs the switch and plugs it back in again, it's in the startup configuration. He doesn't have to reconfigure it, and it'll get around him unplugging and plugging the switch back in again. Okay, oh dear, let me go to the next one because this slide never shows it properly in this thing. So to do port security, by default, it's disabled. By default, if you turn it on, one MAC address only allowed. And the violation, it says shutdown. It's not actually shutdown. That makes you think administratively shutdown. It's error disabled, ERR-disabled. The port doesn't accept any more data as if it were shut down. However, to fix it, you have to type the shutdown command and then wait a second and then type the no shutdown command, and that fixes it. Think of the circuit breaker panel in your house when the circuit breaker goes. You go outside and you look at your circuit breaker panel, and there's one circuit breaker that's just has moved about 1/16 of an inch. You can barely tell it. How do you reset that circuit breaker? You flip it all the way to the off side, and then you flip it all the way back to the on side again, and the light comes back on. So this error disabled status is like that. We have to do a shutdown on the port, flip the circuit breaker off, and do a no shutdown, flip the circuit breaker back on to reset the port for us. This sticky address feature is disabled by default, so we need to configure that manually if we want that to take place. So let's have them learn dynamically. Switch port mode access, switch port security, because it's off by default. Let's turn it on. So by default, only one address is learned. It's put in the MAC address table, not shown in the running configuration. Our malicious intruder from Dallas Community College, if we do this, he's just going to unplug the switch and plug it back in again. That's not going to help us any. So let's do static secure. Okay, this is so cumbersome. Let's see. Joshua, did you get back from getting those 200 addresses yet? Oh, that's okay. That's right. Can't get in, the building's locked. So we're going to write down all these 200 MAC addresses for all of the different devices and then key them in by hand, but that's too much prone to errors. It can be saved, but instead, let's do sticky. We're going to have the switch memorize MAC addresses, which it normally does and forgets after 5 minutes. We're going to have them memorize the legitimate MAC addresses of the student lab computers and the dean's computers, add it to the running configuration. I'll do a copy run start, and then it'll be saved. And if somebody gets into the wiring closet and unplugs, hey, there's nobody at school now, it's shut down, so you can get in easy, can he? Then he can unplug the switch and plug it back in again and do that stuff. So on port 2, for example, switch port mode access, we'll talk later about trunking ports and access ports. Generally speaking, an access port is one that goes to a desktop PC. And a trunking port is one that goes from one switch to another switch to connect to the rest of the company. So we have to set it as access mode because we don't want it to be in a dynamic learning mode. More about that later. Switch port security off by default turns it on. Switch port security maximum 6. Why would I want 6? Don't I want just 1? Well, the default is 1. What if it's a public school environment where the switch port goes to a classroom and they have an old hub with 24 student machines plugged into a hub? I might need to set that maximum to 24 so all those student hubs could be recognized. I can set the aging time to 5 minutes. I can put in the ports, I can put in the address manually if I want to, optionally, static. I can do sticky. I like sticky because it's going to, oh, it says enable stick learning. Well, that's a typo. Enable sticky learning on this interface. Learn it like you would normally. And then what do you want to do when the port detects an unauthorized MAC address? We have 3 things we can do. We'll see that in a second. There's a cute command called switch port host that will automatically disable channeling, like trunk channeling, and automatically force a switch into an access mode, and also something called port fast, which means it'll turn green faster. It'll go past the STP mode and bring the port up more quickly. We have some desktop PCs now. Rather, we have some laptop PCs that boot up in 10 seconds. That's faster than the 50-second delay you normally get when you see that orange light. Okay, here's an example of static addresses. I'm going to key in all those 200 static addresses, and I hope I don't make any typing errors. And only those MAC addresses that were associated with that port will be allowed to log in. No others. They'll generate a violation. Okay, a security violation is going to occur, and what's going to happen here? So this nice looking young man has plugged into the dean's port, and he's the spy from Dallas Community College, and what happens? Well, because we have good security on our switches, he won't be able to get in. We've got three choices here. The protect frames from the non-allowed IP address are not allowed to proceed into the system. They will not be connected. They're just dropped. No log is made. When the legitimate guy, Dean, comes back in and uses his computer, he keeps getting to use it. The next step up is restrict. Frames are dropped from the bad MAC address that's not allowed. A log message is created, and we can also send a simple network management protocol address to the network management workstation, and they can call the campus police and come and track the guy down. The one that he calls shutdown is really error disabled. It's not real shutdown. Now, to recover from it, we must type shutdown and no shutdown. When the switch port goes into the error disabled mode, even legitimate traffic won't work anymore. You can put timers on this where it'll like reset itself after 3 minutes. Otherwise, we got to do it by hand. Okay, DHCP we talked about before. The real legitimate DHCP server for the company is going to assign IP addresses to all the employees' PCs. So if I want to attack this, maybe I'm not an attacker. Maybe I'm just an idiot, like a vice president of marketing. Oh, nobody of you guys work in the marketing department. He buys a Linksys home router. He brings it to his office and he plugs it in to his office plug, and so he can take his laptop to the break room and work from the break room. Oh, that's right. All Linksys routers have a built-in DHCP server. Now we have a rogue DHCP server giving about bad addresses to other people in the company. So we want to be able to stop that. So if I was a real bad guy and I was trying to mess up your company, not just some moron from marketing, I could do DHCP spoofing and put my fake DHCP server on the network to insert myself in all communications. And maybe to make sure that the real DHCP server won't do it first, I can starve him from addresses with a bunch of fake requests. Okay, here's a review of DHCP. Mostly Microsoft machines have this button that says IP address automatically. This means that when the Microsoft machine boots up, he's going to send out the DHCP request, the discover request. He's looking for DHCP servers. In the diagram, you notice there's two servers. Microsoft recommends you have two servers, one to back up the other. You know, Microsoft servers crash a lot. And maybe if I had Linux, I shouldn't do it. But in this case, he's going to send out the discover request, and both servers are going to offer him IP information. The Microsoft machine is going to try to use the one he used before, or maybe use the one that was closest to him. So when that marketing manager plugged his Linksys router, it became closer to that department than the real server, which is back at the company headquarters, and maybe he could give out bad addresses. So he sends out a discover, the workstation sends out a discover, the DHCP server sends out an offer, the workstation picks one and requests that one, and then the server he chose acknowledges that, and the workstation begins to use that, in that case, server number 2's information. So if I were a rogue server, what I would do is put my rogue machine in there, or I was just the idiot vice president of marketing, and I plugged in my Linksys server. Here's my rogue DHCP machine. If I was an actual malicious intruder, I'm closer now than the real legitimate server. So these are DHCP spoofing attacks. There's a solution with the Cisco iOS. We can configure something called DHCP snooping and configure trusted and untrusted ports. Trusted ports will allow the DHCP traffic to flow back from the real server. Untrusted ports will not accept any DHCP traffic, and they can tell it because it's, you know, port 67, 68. They'll block it. This keeps somebody from intentionally or just being an idiot messing up the company technology. So by default, all interfaces are untrusted, and we can use some commands like IP DHCP snooping and tell them which ports are the real DHCP servers. All the other ports will not be trusted, and that prevents the guys from going in there. Okay, when the guy breaks into our system, and he breaks into one, he sends an email that seduces somebody into clicking a dubious link, and it installs some malware on that employee's desktop PC, and then he's going to try to metastatize and get to the good stuff like the servers with the financial information on them. As he hops and jumps through the system, he's going to be creating log files on all these devices, routers, switches, servers, workstations. And if the times on all these are not synced with each other, it's hard to tell how he stair-step through the system. So we want to make sure all the clocks are synchronized. So network time protocol is a protocol that does this. We're going to set up a time server as a definite reference point. And we're going to, in this case, we're going to define R1 as our master time server. We're going to sync him to, you know, the National Bureau of Standards or a CCM clock or something. That's going to be our master time for the whole corporation. Then we're going to tell all the other devices to be network time protocol clients and refer to that server and update your clocks accordingly. Now all the log files are in sync, and we can do this. So the code for this is not that hard. Okay, configuring routers and switches is very similar. When we configure a router, we give it a host name. We set a password for coming into the console port. We set a password for coming in through the VTY ports. We set an IP address for the Ethernet ports, maybe do service password encryption. When we look at the configuration, it's very similar. We're going to give them a host name like S1. We're going to say no IP domain lookup so that if I mistype a command, I'm not stuck in a loop for 3 minutes. Then we're going to go and define what our password is for the console port, password Cisco. The logging synchronous command, what it does is if when you know that, I call this a Cisco annoyance, you type no shutdown and you get ready to type something else and it chops your command in half with the ports coming up and up. When you type logging synchronous, that eliminates that jarring chopping of your line in half and your line stays in one piece. Exec timeout 00 means you never time out. The default in routers and switches is 5 minutes. If you fall asleep after 5 minutes, you're logged off. So if you go to lunch and you have a console plugged in, nobody else can come after you've come to lunch and break into the system. In this case, the switch has a default gateway defined. Routers don't need to define default gateways. They are default gateways. And then at the end, he saved the configuration. We created a management address earlier, VLAN 99. We haven't talked that much about VLANs. We're going to get to that in a later chapter. But in this case, the management VLAN is 99, the switch virtual interface, SVI. And he's defined the IP address for that and done the no shutdown command to bring it up and up. Now we should be able to ping this when we go to command prompt. He can ping, he's pinging the switch from another device and it worked out properly. Normally when you ping a device that you haven't talked to for over 3 minutes, the ARP table will have expired and your first or 1 or 2 pings may request timeout. That's normal operation. Once your PC has learned and updated his ARP table with the MAC address and the IP address correlation, that will go away. Okay, from the command prompt, I can use Secure Shell. Windows supports Secure Shell from the command prompt, or you can use TerraTerm, or you can use PuTTY. So in this case, the users type Secure Shell with the user admin and the IP address of the Secure Shell server, which is a router or switch. And then when he presses the enter key, he'll be prompting for the password. The password doesn't appear on the screen, and there he's connected to the prompt of the switch. He can do something. Okay, in conclusion, how do you clear a switch? Well, if it's a router, you just do the erase startup config. You have to spell it out. It doesn't accept the abbreviation because it's so dangerous. It's clearing out the whole configuration. And after you press the enter key, he's going to say, are you really, really, really sure you want to do this? Confirm this, and then he'll erase it. Of course, the running configuration is still in RAM. If you didn't reboot the switch, you could do copy run start if you did it by mistake. With a switch, we have to do the erase start, but we also have to delete the VLAN.dat file. No fair. What is the VLAN.dat file? We haven't talked about VLANs yet. Well, if you create any more VLANs on a switch other than the default VLAN 1, the VLAN.dat file is what stores all the different VLAN information, and they'll be present in the file system. You can type dir or show flash, and if you see the VLAN.dat file is there from the last guy in another lab, an advanced class did something, you need to erase it. You need to erase the startup configuration file if it's present and reload the switch so you got a nice, fresh operating environment. So the previous VLANs don't interfere with the VLANs that you did. Okay, guys, I think I've covered everything in the chapter that I need to. So when we come back on Monday, I'm going to give you a little packet tracer demo short just to get you going on these two labs. And we're all caught up. Oh, but I forgot to mention this to you guys. When you go into when you go to Blackboard Collaboration, there's a room that's open all the time. Any of you guys can join that room and collaborate with each other when class is not in session. You can talk to each other. I have to turn off your microphones when I'm talking to you because we get horrible feedback and echoes. But you can talk to each other. You can do the feedback all you want to. Just rock out. But just before I start class, I always lock that open room so that somebody doesn't go in there by mistake. Okay, I remembered to record this session, so you can review this session later on by looking in the recorded presentations link. It'll be there in about an hour as soon as it finishes processing. And I look forward to seeing you guys next time. And this is Mark signing off for today.